Hello everyone, we are going to learn various image processing techniques in Python using OpenCV. In this video, we are going to talk about filtration, which is used in image processing to enhance or modify an image by removing unwanted noise, blurring or sharpening feature to extract the important details of the images. For this, we are going to use the Jupyter Notebook. I have already installed Jupyter Notebook in my device. Okay, so first step is to upload the image in Jupyter Notebook to use the filtration. And okay, let us upload the image. Okay, after uploading image, we are going to create the new notebook. After creating the notebook, the first important thing we have to do is to import the libraries we needed for filtration. And the first library we are going to import is the OpenCV, that is import CV2. If you have not installed OpenCV already, then you can do it using the command pip install OpenCV -python. Then use import CV2 to import the OpenCV library. After that, we are going to use import matplotlib.pyplot as plt, and third library is import numpy as np. After importing all these three libraries, we are going to read our image, that is noisy image equals to cv2.imread roses.jpg. Okay. This imread is a function by OpenCV that reads the image from disk and return its numpy array. So let us try to print this image noisy_ng. As you can see, it's giving the array of the image. Now, as we don't need this array, so let us remove this. After this, we are going to use the linear filtration kernel, that is np.ones. We are going to use the 6x6 kernel. Okay. And now, as we have already created the kernel, so we will use cv2.filter 2D function of OpenCV to create the filtration image -1 and img kernel we are going to use. Okay, so in filter 2D is used to apply a 2D convolution filter to the noisy image using the specified kernel we have given. Okay, and the parameter in this filter 2D function is first our noisy image, then this -1 is the desired depth of destination image. By setting it to -1, we are instructing OpenCV to use same depth as source image so that there is no loss of information due to filtering. Okay, and this is our kernel. So let us print this image plt.imshow img. Now, if you implement this function plt.imshow, then you can observe that the color of the image is changed from the original image. This is because OpenCV uses the BGR order of coloring as compared to the general coloring method, that is RGB. But no need to worry, let us convert it to the RGB. cv2.convert function color our image, then cv2.color_bgr to RGB. Okay, here we have the same color of our image and the resulting filtered image. Okay, wait, we are going to use this function This function is not for filtration but to actually show the original image and the filtered image together, so you can analyze how the image is changed by the filtration. Okay, so we are going to plot our image, our original image, that is noisy underscore ng, and our filtered image. Now we can observe the changes after filtration in our new image from the original one. Similarly, we have applied various filtration techniques. Let us go through all the filtration techniques. This is linear filtering we have studied. Then there is Gaussian blur function. Gaussian blur is used to apply the Gaussian blur filtration. It is a type of low pass filter that smooths the images. Okay, for this we are going to use this Gaussian blur function of the OpenCV, and the parameters we are going to pass in this function is our noisy image. Then this 5,5, it is to specify the size of the Gaussian kernel. Then the sigma x and sigma y is to determine the amount of blur applied in each direction, that is in the x direction and the y direction. Okay, that's 5 and 1 is not compulsory, you can change according to your wish. And then we are going to plot the image using the function plot underscore image. Okay, and this is the result of Gaussian blur. This is the original image and this is the Gaussian blurred image. Okay, so in order, let us go to the sharpening of the image. For the sharpening of image, we are going to use this kernel, that is -111, and in center we have 9. Using this array, we will sharpen our images, and using the same filter 2D method of OpenCV as what we have done in the linear filtration. Then parameters will be our noisy image, then depth -1, and the kernel for sharpening, kernel 2. Now we have plotted our image and the result is as shown, that this is the original image and this is the sharpened image. As you can see, all the edges and all the flowers, roses are sharpened in this image. Now as we are playing through the filtration techniques, we are going to create one more filter, that is emboss filter. Emboss filter is like -1 in one diagonal and 1 in other diagonal, and all other elements of this array is 0. Using this kernel, we are going to implement in the filter 2D method. Depth will be same -1, and kernel, this is the result of the embossed filter. Okay, hope you enjoyed this video. Thank you.